Hello friend, in this video we are going to learn about aldol condensation reaction. So aldol condensation reaction can be happen in mainly two conditions. One is base catalyzed, another is acid catalyzed. So right now in this video we will learn about the aldol condensation by base catalyst. In the another video separately we will also learn acid catalyzed reaction. So let's start. What is the principle for aldol condensation? That is, aldol condensation will begin with the addition of enolate. Enolate can be also known as enol, right? So enolate will be added to the carbonyl. Carbonyl where the nucleus of carbonyl. Nucleus means positive charge. So we are going to add enolate on the positively charged carbocation of the carbonyl, and this will happen in specially aldehydes and ketone will lead to the product beta hydroxyaldehyde or ketone. Whatever your starting material you utilize, that will be your product. So on the beta position you will get hydroxy. Oh, okay, either you took aldehyde or ketone, right? And later you can do the dehydration process which will leads to the product alpha beta unsaturated carbonyl system. So in very short, in simple word, we are taking either aldehyde or ketone for the reaction in presence of base catalyst. In this video we will learn about base catalyst. Another separate video is for acid catalyst also is available, right? So in the base catalyst, first we will get beta hydroxy. Whatever you utilize, aldehyde if you utilize, you will get beta hydroxy aldehyde. If you utilize ketone, then you will get beta hydroxy ketone. So that is all about the principle of the aldol condensation. Let's see the reaction. The reaction is base catalyzed. So we took weak means diluted NaOH up to 10%, up to 10%. And as you can see, the starting material taken is acetaldehyde. Acetaldehyde here CH3, here CHO, right? In presence of weak base, you can see this is carbonyl carbon, this is alpha position, that is beta position, right? On the beta position, we are getting hydroxy by this reaction, and that is called aldol product. That is called aldol product. In our some textbooks, we are getting a double bond over here. That is alpha beta unsaturation, but that can be done after dehydration process later. Let's see how is happened. Yes. So mechanism for this reaction, you can see the first step is formation of enolate ion. How it can be formed? We just have to take base catalyst which will react with the acetaldehyde and the alpha hydrogen. You can see the carbonyl carbon is this one. So this carbon will be called as alpha carbon, and the hydrogen present on the alpha carbon. Hydrogen present on the alpha carbon is known as alpha hydrogen, will be affected by the base. Base will donate its electron to the alpha hydrogen, and the hydrogen will goes with the base, right? So the hydrogen will be removed by the base by donation of the electron to the hydrogen. So hydrogen will be removed and the H2O will be a byproduct. Why? Because the H goes with the OH minus, right? So after that, the electron will be shifted toward this carbon, right? And this carbon will become negative. But here carbonyl will get inductive effect of that, and the electron will be shifted toward the oxygen. Oxygen will get now more electron and it will get negative charge. And the charge negative is here. Negative charge is here. Carbonyl carbon will become positive. That will leads to a formation of double bond. So that is called enolate ion. What is enolate ion? The en means alkene. Ol means alcohol. Combination of en plus ol, enolate. That is called enolate ion. And this may also get tautomerized. This may also get tautomerized to this way, right? The bond's electron will shift over here. So positive charge will be generated here. The electron came here, so charge will be negative. That is here. You can see. And the double bond get broken. Double bond get broken. Now the positive charge between the carbonyl carbon and the oxygen will leads to a formation of pi bond by sharing of electron. By sharing of electron. So that will do what? That will make tautomerize into both position equally. Right? That may get tautomerized. Now in the next step, first step is formation of enolate ion. Now next step is what? Just we are going to see. Yeah, in this step what happened? A hydroxide ion removes a proton from the alpha carbon and leave to the resonance stabilate enolate. Now in the second step, the addition of enolate to the carbonyl carbon. Addition of enolate. Here whatever enolate we generated, that will be added to the nucleus. Nucleus means positive charge carbon, right? And that is what? That is the addition of enolate to the carbonyl carbon. To the carbonyl carbon. It is very simple. You can see double bond is here, but if you break it, the electron will shift here, will create negative charge and the formation of carbonyl, right? So formation of carbonyl, negative charge here, it is having pair of electrons. That will be donated. The electron pair will be donated to the positively charged carbon due to the generation of electron will shift here. So oxygen will get negative charge, positive charge will be generated here, and the positive charge will create a bond between this carbon and this carbon, and this carbon and this carbon. So sorry, that's mistake. Yeah, you can see that this carbon will be donate its electron to here, right? So that is very simple. It will stick here and double bond, as I told, it will created here. So that is the formation of an alkoxide ion. Alkoxide ion, right? So alkoxide ion will be formed in the second step. Now next, what is the process happens in this state? Enolate that attacks to the nucleophile and attacks the carbonyl, and second molecule of acetaldehyde will join with that and producing an alkoxide ion. Now the third step, protonation. Whatever alkoxide we prepared, we take the water, the proton will get attached here by electron donation from the alkoxide ion. Electron will be donated here. Now the bond will break. Oxygen will get electron from the bond. This will break and O will get hydrogen. O will get hydrogen. So that is aldol product. That is aldol product. And base will again came out as we take it earlier as a catalyst. What is catalyst? That we know any reagent which acts as a catalyst will further come out after the reaction, right? So that is the complete mechanism for the aldol product. But in some textbook, we are getting the double bond over here. How it formed? That is by dehydration process, right? So alkoxide ion, now removal of proton will be there, and aldol product as we found. Now aldol product will lose one hydrogen, water molecule and convert into the double bond alpha beta unsaturated. That is called dehydration of aldol. That is called dehydration of aldol addition product. Now how it happens? This is aldol addition product, beta hydroxy compound, right? Now what will happen? In presence of base, the electron, in presence of base, the electron will be donated to the hydrogen in alpha of the carbonyl, right? Hydrogen donates its own electron to this carbon. So this carbon will become negative, right? And the electron will shift it towards oxygen. So electron will shift towards the oxygen. So positive charge may generate over here. Positive charge may generate over here. If you see, the positive charge is here and negative charge is here. So now after losing hydrogen over here by base and one OH from here, simply formation of a double bond will take place. How? You can see, as I told, OH will be removed and one electron will shift here from by the enolate ion that will tautomerize, and you can get a electron negative here, positive negative charge will create a double bond here, that is enal, and the compound is alpha beta unsaturated hydroxy compound. So removal of water will give you dehydration, will give you the alpha beta unsaturated aldehyde or ketone, whatever you took. Here we took aldehyde, so the product is alpha beta unsaturated aldehyde. So that is very simple. I hope you all will get the exact idea about the aldol condensation in presence of the base catalyst, right? So double bond of carbonyl alkene and carbonyl group are conjugated and stabilize the product. So this will be stabilized, right? So that is the way how the aldol condensation will take place in the basic media. Thank you very much for listening me patiently. Thank you.